Okay, welcome back to members of 121 Community Church in Grapevine, Texas, and our ongoing study in the mind-gut connection by Mayer. We're into a very powerful chapter, chapter 3, it'll be pages 51 to 75, and we finally get a closer look at communication. Let's go to block 1, and the gut's layered and diverse receptor cells. Receptor molecules are located on sensory nerve endings, and they do participate in the gut-brain dialogue, called phytochemical receptors. 28 have been identified. They are responsible for food metabolism and for the release of hormones to the brain. Which send healing messages to the brain and the body. And they are the endocrine cells in the gut that release these different hormones. So communication flows in the following order. You have the sensory gut lining cells providing sensation. The next layer is the endocrine cell, and then you reach the neurons. The endocrine cell communicates to the deeper neurons. So endocrine cells play a central role in human well-being. They actually reach the gut-brain channel of communication. There are also immune cells called dendritic cells that also cut across the gut lining and communicate to the vagus nerve bundle. And so you can see that we're talking about that ability to transcend the gut function and to make the leap to actually synapse connection to neurons. And then once that synapse connection to neurons is made, then information travels upward up the vagus nerve bundle to the hypothalamus. So block 2, we're talking about the encoding of intraceptive information. The brain receives cues from the gut. The brain integrates this data with other environmental data received, and the brain monitors the ENS system. The brain is continually receiving this intraceptive information from the vagus nerve bundle. So block 2, note 2, through the vagus nerve bundle, information travels to the limbic brain and the hypothalamus. And the hypothalamus is the link, the necessary link between the endocrine system and the nervous system. The link between the endocrine system in the gut and the nervous system in the brain is the hypothalamus. It has a critical mediating role that makes that connection possible. So the endocrine system is connected to the nervous system through the hypothalamus at the base of the brain. At the top of the vagus nerve bundle, which connects to the base of the brain, you have the hypothalamus. And so it plays a very critical role. And so in block 3 we can talk about, in this chapter finally we can talk about tapping into memory function and tapping into cognition through the hypothalamus. It is through the mediation of the hypothalamus. All right, block 3, note 1, the gut-brain axis ensures our mental and physical well-being through a dense distribution of information through a nerve bundle of about 100 trillion neurons and microbiota. In this lesson, in Chapter 3, we will now recap this dense communication channel. We begin with epithelial cells with their microvilli. They are the sensing cells in the gut. They are the sensing cells in the gut. Then we move on to the enteroendocrine cells. They make up the transition layer of cells that make synapse connections to the neurons in the ENS, in the vagus nerve bundle. So the neuroendocrine cells are critical. They turn sensation into information. And then we have the neuron cells in the ENS that travel upward to the hypothalamus. Now, the hypothalamus is a 3-region hypothalamus. In the anterior region, it emits mental stress hormones. Remember, in the endocrine system, communication is hormonal. In the nervous system, communication is electrical. But in the endocrine system, communication is hormonal. Then you have the middle hypothalamus. It emits body development hormones. And then the posterior, which is the deepest region before you get to actual nervous system, it enhances memory function, and that, of course, applies directly to cognition. That is a key point. If you really want to key in on the significance of this Chapter 3, it is most certainly that recap of the dense communication channel that reaches the 3-region hypothalamus. So let's do a quick little recap. In Block 1, we want to talk about Note 2. Endocrine cells in the gut release different hormones. And communication flows in the following order. You have sensory gut lining cells, then you have endocrine cells, and then the neurons. And so we want to take that away from Block 1. We have the following order for the flow of communication. In Block 2, we want to talk about Note 2 also. Through the vagus nerve bundle, information travels up to the limbic brain and the hypothalamus, which is the mediating organ between endocrine system and nervous system. The hypothalamus is critical. It makes possible communication between endocrine system and nervous system. So we've got to go with Block 1, Note 2, Block 2, Note 2, and then Block 3, Note 2. There you go. All right. And that's a recap in Block 3, Note 2. The dense communication channel begins with epithelial cells with their microvilli. They are the sensing cells in the gut. Then you have the enteroendocrine cells, their transition layer. They make actual synapse connections with neurons in the ENS, in the vagus nerve bundle. So the endocrine cells are critical. And then the neuron cells, they travel upward with information to the all-important hypothalamus that mediates between the endocrine system and the nervous system. And the hypothalamus is 3-regioned. Initially, it will communicate mental stress hormones, then it will emit body development hormones, and then at its most deepest and most significant, it actually will communicate hormonally in a way to enhance memory function, which directly serves cognition. And so we can say there is actually a link a neurological link between the endocrine system and the nervous system that will touch on memory and even cognition. That's very significant. That's a huge, huge issue. We're finally, by page 75, we've really gotten into the meat of the book now. And we already discovered in the previous lesson that we have a hormonal release that serves motivation. Well, if you couple that motivation function with the memory function, that's very significant for theology and for philosophy and for phenomenology and critical neurophysiological correspondence for what we discuss in philosophy of mind or theology of mind. And specifically, phenomenology that is very popular today, because phenomenology begins with the sensate. Phenomenology begins with sensation, so this plugs in very definitely with phenomenology that is so popular today. So for me, I like the idea that he's not excluding the larger picture when he gives us the finer details. Mayer gives us the larger picture that it is the hypothalamus that serves as the link between the endocrine system and the nervous system. And that communication to the hypothalamus begins with sensation in the gut, in epithelial cells. They, in turn, speak to endocrine cells. They, in turn, speak to neuron cells. And neuron cells travel upward and speak to the hypothalamus. And the hypothalamus is a three-tier hypothalamus that deals with mental stress, body development, and then at its deepest, most penetrating function, the enhancement of memory. And the memory function is a very important part of cognition. So in chapter 3, we finally reach that point of how does all of this reach cognitive importance? So as I said before, and I'll say it again, I think that Mayer is doing a good job of allowing a layperson like myself to still get into a very detailed analysis, and he's maintaining the larger picture as he articulates the finer points. So that's going to wrap up pages 51 to 75 in chapter 3. And our next lesson is going to run page 75 to 107. 75 to 107, that will be chapter 4. 75 to 107 will be our next reading.